lasers used to create negative Ma.ss particles. All the matter you've ever interacted with has mass, and as such it obeys the standard laws of motion as enunciated by Newton centuries ago. If you push something, it moves in the direction you push it. However, matter with negative mass would do the opposite. It sounds like wacky science fiction, but it's close to becoming reality. Researchers at the University of Rochester have worked out a way to create negative mass particles using, what else? Lasers. Is there anything lasers can't do? Physicists have been chasing real-world examples of negative mass for years, but it's all been theoretical until recently. The math predicted negative mass was possible, though. In the classic physics equation for force, F equals ma, all three variables are positive. However, if you make mass a negative number, the resulting force is negative as well. Thus, pushing an object with negative mass causes it to accelerate toward you. Try to pull it toward you and it'll move away. It's a real mind-bender. The University of Rochester team says the new experiment published in Nature Optics is the first example of creating particles that exhibit negative mass. In the experiment, a laser bounces off mirrors within a small optical cavity. The key to generating negative mass particles was the use of an ultra-thin semiconductor made of molybdenum diselenide. The photons on the laser and excitons in the semiconductor then interact to produce the negative mass effects. The Alcubierre warp drive makes use of negative mass. We're getting into serious condensed matter physics here, but the gist is that an exciton is a bound quantum state of an electron and an electron hole where an electron could exist in the semiconductor. The end result of this interaction is a new quasi-particle called a polariton that has negative mass. The researchers verified negative mass qualities in the experiment, but we're a long way from harnessing that power to actually do something. Lead author Nick Vamivakis describes a way negative mass particles could be employed in, you guessed it, lasers. Applying an electrical field across a device with negative mass particles could allow researchers to apply push and pull forces with much more efficiency. With polaritons, it's possible to generate a laser with much lower energy input. Taking things to a more sci-fi place, negative mass is also one of the requirements for the theoretical Alcubierre warp drive. Of course, we're a long way from figuring out how to make